Hi, I'm Keith McCormick from Qubit. I want to tell you just a little bit about this preview. Each month, we get together with our clients and we do our SPSS Statistics seminar series. What we've done is we've chosen a short segment from one of those, and it's not necessarily the first few minutes. What we've done is we've tried to choose a topic that in and of itself is going to be interesting and valuable to you. And obviously, we hope that you seek out more previews like this on this channel, or that you approach us about our other training offerings. Hope you enjoy the preview.
Sure, I do have some additional material on identifying unusual cases. So since we do have it's another way of doing clustering. Although the idea here is that you are identifying just your outliers, your unusual cases, things like that. So we'll start off with a little bit of a PowerPoint slide. And then we'll go through a demonstration and go from there. So the general idea in terms of identifying unusual cases, unusual data is not always going to be a cause for concern. Sometimes unusual cases can be errors in the data. Okay, we might have a teacher that has a salary of $1 million. Well, we may have just added in an extra zero as we were entering in the data. So sometimes, identifying these kinds of unusual cases, it's great. We're able to then go back in the data and fix those errors. Sometimes you might have unusual cases where it's just an extreme score. Maybe it's a customer that ended up purchasing 5,000 speakers in the last month, where typically orders range somewhere between 100 to 1,000 speakers per month. Great for us. Who knows what might have been going on with that customer. They might have had a really special event or something like that, and they ended up buying something that was a little bit out of the ordinary for them. Sometimes you might have unusual cases that are just interesting. In this example that I have here, a patient with cystic fibrosis might be 52 years old, where the average life expectancy for a person with this disease is only in the mid-30s. So again, we may want to go and further investigate that, but that might be for clinical reasons. Sometimes unusual cases can be really valuable. Maybe it's a small group of customers that really use their cell phone a lot. And so this group is valuable as customers, but because they're so different than your typical customer, you might want to analyze their data separately so it doesn't distort the findings of your typical customers. And sometimes unusual cases are going to be a real cause for concern. We might be talking about something like fraud, for example. So, there's a lot of reasons why cases might be unusual. In any case, whether we're talking about outliers, unusual cases, anomalies, whatever you want to call them, they can be problematic for statistical techniques. By definition, an outlier is just a data value that's unlike all of the other values. It's different. And you can be an outlier on a single variable. For example, you might be an outlier in terms of number of stereos that you've purchased, for example, and that person that purchased 5,000 stereos, for example. Or you can be an outlier on a combination of variables. Detecting outliers can be pretty simple. If you're just an outlier on a single variable, you might just be using things like frequencies or graphs to be able to detect them. You might use a histogram to be able to detect outliers. You might use something like a bar chart, okay, if you're just talking about an individual variable. It's also generally pretty simple to identify outliers when people are outliers on a combination of 2 or 3 variables. For example, we might use a scatter plot to look at the relationship between 2 continuous variables, and we see one case that's just way out of the norm on that combination of variables. However, being able to detect unusual cases on a combination of many variables is going to be almost impossible to do manually. Okay, and so that's where the identify unusual cases technique ends up becoming really useful. It's going to allow you to identify unusual cases on combinations of many, many variables. And it's going to do it in an automatic way. And like I said before, this technique is really based on the 2-step clustering technique. The basic idea is that you're going to do cluster analysis on the variables that you select. And because it's 2-step, you can use both continuous variables and categorical variables. Okay, so you don't necessarily have those limitations that you might have had with other clustering techniques. So you're basically going to do cluster analysis, and you're going to end up creating groups of people groups of cases that are similar, and those are going to be the clusters that you end up defining. The cases that you then put into these different clusters, those cases are going to be compared to the group norms. And then cases are going to be assigned what's called an anomaly score, an unusualness score. So the larger this anomaly score is, the more that it indicates that a case is deviant or unusual. And typically, we end up looking at cases that have anomaly index scores values that are greater than 2. And that basically what that means is that that person, if they have an anomaly index value of 2, it means that that person is, their deviation is at least twice the average of your typical person. So they're a bit different. And, you know, basically we end up looking at these cases and we end up looking to see, you know, what might be unusual about them. You might decide to, you know, further analyze that data. You might just look at that data and see if, you know, there might have been errors in the data, things like that. What's also nice about the identify unusual cases technique is that not only does it tell you which cases are unusual, so then you can investigate them further, but it also tells you on which variables those cases are most unusual. So now you know not only which cases to further explore, but also what variables you might want to look at to see, you know, it might be the way people understood a question. Maybe the question itself from a survey was not that clear or something like that. To do the, to use the Identify Unusual Cases technique, you're going to go up to the Data menu. You're going to click on Identify Unusual Cases. This is what the Identify Unusual Cases dialog box looks like. You'll have to put in whatever variables you want to put into the analysis variables box. If you happen to have an ID variable, you know, any kind of identification variable, put it into the case identifier variable box. And that's going to make things a little easier in terms of identifying those unusual cases. Notice that you know, I'm able to just put in all of my variables in the analysis variables box. What variables would you put in? Any variables that you are thinking of including in a predictive model, for example. So you're looking for combinations of people on all of these variables. I just added all of them in there for this example here. Now, note that you want to make sure you have the correct level of measurement for your variables, because that's going to affect the way these results are calculated. Okay, so you want to make sure you have the correct level of measurement there. I'm just going to go quickly through some of the different options that are available. Under the output dialog box, the Identify Unusual Cases output dialog box basically allows you to specify what kind of. So the first option, this one is selected as a default, list unusual cases and reasons why they're considered unusual. It's going to tell you which cases are unusual. It's going to give you some information concerning what groups they're in. It's also going to give you an anomaly index value as well, and also the reason why the case was considered to be unusual. You can then also end up getting some summaries, summaries on the different groups that were created. Also summaries on the anomaly index variables, and you can see what things typically look like for those cases that were unusual. You could also get a summary on the reasons why, which variables were the ones that were considered the reasons why people were unusual, and then also how many cases were included as well. Under the Save tab, this just lets you save different variables, and you might end up saving these different variables. So then, you know, maybe you might want to sort your data based on the anomaly index score, for example. You know, like I said, it does do cluster analysis, so it's going to end up saving the peer groups so that you know what cluster each person belonged to. And the reason
I've got a question that is a clarification of what you're covering now. So so I thought I would jump in with this one. I'm just going to go ahead and read it. What does correct level of measurement mean? Like that the data are standardized on the. Is it the same or not the same as standardization?
Oh, okay. So By level of measurement, in SPSS statistics, there are 3 different levels of measurement. There are nominal level variables, ordinal level variables, and scale level variables. Scale level variables should be anything continuous, variables like income, for example, variables like age, things like that, where the numbers actually mean something.
You know, it occurs to me, Jesus, that it may not be clear to everybody where that's defined.
Okay.
But we would have a chance to see that in the software, I think. So maybe actually we should hold off on that one.
Sure. I'll mention it when we go through the software demonstration then.
Well, or I guess we could clarify for everybody that that would be done in the variable view, not in identify unusual cases itself, if that makes sense.
Yeah. So I'll mention that when we go through the software demonstration. So yeah, under the Save tab, these are just different variables that you can end up saving as you run this analysis. And again, you'd want to save these variables potentially so that you can do further analyses on them or help you sort your data in a certain way so that you are able to better see who those unusual cases are. Under the Missing Values tab, this dialog box just basically controls how you're going to handle missing data, whether you want to include them or not include them in the analysis. And then under the Options tab, this is where you end up specifying criteria for how you're going to identify unusual cases. You could identify unusual cases based on a certain percentage. The default there is 5%. Or you could use a fixed number of cases, the cases that have the highest anomaly values. Maybe you want to look at the 10 cases or 20 cases that have the highest anomaly. So you could choose those cases based on that. You also have the option to identify only those cases where the anomaly index value meets or exceeds a certain criteria, and the default is set to 2. Also, notice that you have the option to specify what the maximum number of reasons are. The reasons, remember, are the variables on which the people are the most unusual. The default is set to 1, but you certainly can change that over to something else if you'd like. And the final option there is number of peer groups. Again, because this is really 2-step that's running underneath, 2-step as a default runs everything from the 1 to the 15 factor, from the 1 to the 15 cluster solution. And so that's basically what's going to be done here as well. The identify unusual cases procedure is going to end up trying out different solutions, like I said, as a default 15 cluster solution. And it's going to give you the one that makes the most sense from a statistical standpoint.